Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So I'll show you something and look and observe what is happening there. Okay.
Okay, ma'am.
There is a man. He's eating the banana, and he threw that in the rod itself, and he himself is slipping on that. Right.
Yes, ma'am.
Yeah. Now, in here, in the second case, there was a banana peel, and this guy, he is slipping on the banana peel and is falling down. So, why do we fall down when we step on a banana peel? We have experienced this, right? When there is a banana peel. What did you say, Pranati?
Friction is very low, ma'am.
Okay, Pranati is saying it's due to friction. Friction is very low. Okay, we'll see that. Okay. Is there any other answer? Mahidhar, what do you think? Why is he falling down?
Don't know, ma'am.
Okay, today we will see why is this happening. Okay.
Okay, ma'am.
Yeah. Now, tell me, you can answer through the chat box also. I will check your answers. It will be slippery. Yeah, Krishna Kumar is saying it will be slippery. Yeah, it will be slippery. So, which is easier? To walk on a wet floor or on a dry floor? Which is easier? In which case you will fall down. Easy is there is a chance of falling down. Okay, yeah, I'm getting. Yeah, everyone is agreeing to that. It is easy to walk on a dry floor, right? So,
Yes.
I've seen this caution board somewhere, something like this. So there is an yellow board, and it shows in that there is a triangle, and it shows that someone is falling down. That symbol is there. So why is it kept? Have you seen this somewhere?
Yes, ma'am.
Yeah, if there is dangerous, wet floor will slip. Yeah. So where do you see that? Where did you see this caution board? Usually.
In highways, ma'am.
Highways?
Not slippery, but ma'am, this
No, ma'am. On malls, we'll be seeing this, ma'am. While they clean the floor, they will keep the caution board.
Yeah,
Don't go on this side. In bridges.
In bridges? In bridges is this caution board I'm saying, not the...
In malls, they will keep, ma'am.
Yes, ma'am.
Yeah, in malls.
Not will be.
Okay, I'm getting Pranadi's answer. Mahidhar is saying something?
Ma'am, if that is a caution, it will be in malls, ma'am. If another caution means it will be in bridges or in another places also, ma'am.
Yeah. So you're talking about generally the caution boards. So look at this caution board. Something is special about this one. So in this caution board, it is shown that we can slip. There is a chance of slipping. There is a chance of falling down. So where do you think this will be kept? Will this be kept in bridges?
No, ma'am.
It will be kept in malls. Pranati, you are saying it will be kept in malls. So in which area usually this is kept? Can you say that? Pranati?
Wet area.
Wet area. Yeah, wet when after cleaning or like when floor is wet, this is kept. Usually we can see this in bathrooms area because there will be water everywhere there. There is a chance that water will be there. So, yeah, why is it difficult to walk on a wet bathroom floor? So you're talking about generally the caution board. Padma, can you try? Something is special about this one. So in this caution board. So why is it difficult? Why do we fall down when we are walking on a wet floor?
Ma'am, because friction is less on that floor, ma'am.
Yeah, Sirishma is also saying friction. So what is friction?
Kept in, yeah, in malls. Pranati, you were saying it will be kept in malls. So,
Ma'am,
area. Usually this is kept. Can you say that?
Yes.
Pranati area. Wet area. Yeah, wet. Then after cleaning or
Okay, today we will see all this. Why? What is the exact reason? Why is it all happening? Okay, so I have got Sirishma and Pranati saying something about friction. So let's see what is that. So to understand all this, let's look into this. So here we can see a table, right? There is a table and there is a block. There is a box kept there. So I have kept a box. A box is here and a table. So I'm going to push this box. Okay? Observe, I'm going to push this box. Yeah, it is moving. But then what happened? See, it is moving. So when I gave a push, it moved. And then what happened?
It stopped.
Stopped, ma'am.
Yeah, it is stopping. So why is it stopping? Why is the box moving continuously?
Because you applied only
You have
little
applied
force.
push, ma'am.
Because it going on the surface, ma'am.
Because going on the surface, I applied less force.
What happens there?
Yes, ma'am, you applied less force.
Okay, so I'm getting so many answers. So if I apply more force, will the box be continuously moving without stopping?
No,
Yes,
ma'am.
ma'am.
It will stop at one place.
Yeah, now Sudhir, is that Rajarajeshri? Yeah, Rajarajeshri is saying it will stop somewhere. So is everyone agreeing to that? The box, how if I give so much force also, it will stop at some time.
Yes, ma'am.
Yes, ma'am.
Yeah, it will stop at some time. So what is happening is, so when I'm pushing a box, so something is pushing it back. So if I give a force in this direction, something is pushing it back. Correct? That's why it's stopping. So something is cancelling the force I have given to the box. Correct? What do you think? Is that a plausible reason? So can we say some force is responsible for this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am, we can say.
So some force is responsible for this stopping. So then, can you identify that force? Sure. Can you guess this? So we have studied so many types of forces, right? So let's look. We have studied two types, contact forces and non-contact forces. So which is this force? Is there a contact force?
Contact force, ma'am.
Force.
Yeah, I got 4 answers contact force. Let me check. Yeah, Mokshita, can you try? Will that be a contact force or a non-contact force?
Contact, ma'am.
Yeah, Mokshita is also saying contact force. Is anyone having a difference of opinion in that? Will that be a contact force or a non-contact force?
Contact, ma'am.
Contact force, ma'am.
Yeah, it will be a contact force. So, since it is a contact force, can you identify the surfaces which are in contact here? So, there is the table, box and my hand is pushing that. In where is the contact happening? So, some force is responsible for stopping the box. Tell me.
The table and the brick, ma'am.
Ma'am, the surface of the table in the box, ma'am.
Okay, and I got 2 answers. Can you answer to chat box, others? So I got only 2 answers. So they are saying that it is the box, the surface of the table and the box. Yeah. Yeah, Samyukta, what do you think? Yeah, now Mokshida has also given that answer, that surface of the table and the box. Mokshida, what do you think? Which are the surfaces which are in contact? Samyukta? Yeah. Can you identify the surfaces in contact here? So we have said that it will be a contact force. So identify the surfaces which are in contact.
Table, ma'am. Surface of table.
Okay, there is one surface of the table. Then there should
Ma'am,
be
and the contact between hand and the box also contact is there, ma'am.
hand. Okay, we are talking about the force which is responsible for stopping the blocks. So is the hand, so are you saying, Sirishma, the hand and the box are the surfaces where this
No,
force
ma'am.
is acting? Oh,
No, ma'am.
okay. Now, Samyukta, can you continue? So you identified one surface of the table. So,
Mokshita.
okay, it was Mokshida. So Samyukta can you talk? So can you answer? I got Mokshida's answer in the chat box here. So Samyukta? Okay, you can answer through the chat box. Okay then. So as everyone has identified, the force is acting between this box and the tabletop. That force which is responsible for stopping the brick. Okay. Now, can you identify which direction that force will be acting?
Opposite direct, ma'am.
Opposite.
So I got two answers opposite.
Yes, ma'am, opposite direction.
So I am giving a force in this direction. So the force responsible for stopping it will be in this direction, correct? In the opposite direction.
Yes, ma'am.
Yes. So as Sirishma and Pranati was saying, the force which is responsible for this is friction. So do you remember what is friction?
Yes, ma'am.
Yes, ma'am.
Okay, tell me
Yes, ma'am.
what all you remember about friction.
When two objects are in contact, automatically after some time it will stop, ma'am. The force which stop an object is called friction, ma'am.
Okay, when two objects are in contact, automatically they will stop. Are they moving? So to stop, they should be moving, right?
Yes, ma'am.
Yes, ma'am. Friction will takes place while the object is moving and it will stop. Means it will make that object in rest, ma'am.
It will make the object in rest. Okay, so I'm getting close enough answers. Yes. So can we say that friction is a contact force? So it happens only when there is a contact. Is everyone agreeing with that? So friction happens only when there is a contact. And it will be acting, it comes into play when there is a motion between two surfaces that are in contact. That is what Pranati and someone else was trying to say. So, yeah, so it comes into play when there is motion between two surfaces which are in contact. And what will be the direction of friction?
Opposite direction.
Opposite direction.
Opposite direction to the applied force or the motion, right?
Yes, ma'am.
Yes, ma'am.
So it opposes motion. Right? So I'll state all this in one statement like this. Friction opposes relative motion between two surfaces in contact. Okay. So can you write this down? Friction opposes relative motion between two surfaces in contact. Correct? So what do you mean by relative here? So I have added a term relative. So let's look at the table and the box. So this is my table and this is the box. So now when I push the box is moving. So box is moving with respect to the table, right? So that is what I meant here as relative. Okay. So, yeah. Rajeshwari, can you read this last statement? So this one.
Friction opposes relative motion between two surfaces in contact.
Yes, so friction opposes relative motion between two surfaces in contact. Now, so can you see the ball moving?
Yes,
Yes, ma'am.
Yes, ma'am.
It starts here, it starts from here and it's moving here. So at some 70 seconds, it's stopped, right?
Yes, ma'am.
So at 1 second, the ball's position is there. And now the box at 57 seconds is here. So can you tell me why does the moving ball stops rolling after some time? Yeah.
Because friction acts.
Okay, because friction acts, Varun. So it's Surishma. Okay.
Yes, ma'am. Friction opposes and it will make the ball to come in rest position.
Correct, excellent. So friction is the force which is responsible for stopping this ball, stopping the motion of this ball. So can you identify the direction of friction? So I will ask Nagalakshmi, yeah, Likhdeshwari, can you identify the direction of friction? So now the ball is moving in this direction. So what will be the direction of friction? Likhdeshwari, can you try?
Said, ma'am.
I heard said. So can you try? Can you say it again? I couldn't hear it properly.
Right side, ma'am.
Okay, this is the right side, right? So this is the left side and this is the right side. So now, can you tell me which is that side? Friction is acting in which direction? Okay, this is the right side and this is the left side. Nikiteshwari, can you try? So the ball is moving in this direction. So ball is moving towards right. So which will be the direction of friction?
Left side, ma'am.
Okay, now Pranati is saying left side. Likideshwari, can you try? Okay, she is not here. Okay, Likideshwari, what do you think? Will it be in left side or will it be in right side? The frictional force, the direction of frictional force?
Left side, ma'am.
It will be towards left because friction is an opposing force. It will always oppose motion. So if motion is in this direction, friction will be in the opposite direction. That will be from right towards left, okay? So since the motion is towards right, friction will be towards left. Okay, then, so here a girl is likely. So when you stop pedaling, the cycle comes to a stop. So it's finally, so when you stop pedaling a bicycle, it gradually slows down and finally comes to a stop. Why? Why is that?
Ma'am, because we are not applying force, no, ma'am.
So since we are not applying force, okay, that could be an answer. Yes, Mahida, that could be an answer. So
And friction will opposes the cycle, ma'am.
Friction will oppose the cycle. Okay, Mahidar, now let's look into this situation where after you are pedaling and you need to come to a rest. So then what happens? So what will you do?
We will use the brake, ma'am.
Okay, we will use the brake. Yes, so then what happens? So the cycle is stopping, right?
Yes, ma'am. Cycle.
Yes, ma'am.
Yeah. So can you now try? When you stop pedaling a bicycle, it gradually slows down and finally comes to a stop. So if I apply more force there, so if I'm continuously pedaling, yeah, it won't. Yeah, it will.
It takes some time to stop, ma'am.
Yes, ma'am.
Yeah, if I continuously pedal, then the speed of the bicycle will be increasing and it will, to come to a rest, it will take some time, right?
Yes, ma'am.
Okay, we'll take this scenario to the last of the class. Towards the last of the class, we will discuss, okay, what happens when we apply brake.
Okay, ma'am.
Okay, ma'am.
Okay, now, as I think Pranati was saying, the slowing down, it is because of friction, right?
Yes, ma'am.
Just now, Pranati, yeah. So, which are the surfaces that are having contact here? Identify the surface.
Road and
cycle.
cycle.
Road and cycle, ma'am.
Road and cycle, ma'am.
Yes,
Okay,
ma'am.
cycle is this big. So, which part of the cycle and the rod?
Wheels, ma'am.
Wheels, ma'am.
Yeah, so I got two answers, wheels and the rod. So, yeah, Charan, what is your answer? Charan? Nandu, can you try? Which are the surfaces that are having contact here?
Rod and wheel, ma'am.
Yeah, rod and the wheels. So rod and the wheels. Now can you identify the direction of friction? So the girl was moving towards right. Right. So can you identify the direction of friction? Okay, I'm getting an answer. Pranati, yeah, okay. Okay, let me ask. Phanindra, you there? Phanindra, Phanikumar? Can you try the direction of friction? Okay, you can answer through the chat box also, no problem. And Ramya?
Yes, ma'am.
Okay, which will be the direction? Can you predict the direction of friction?
Yes, ma'am.
Okay, tell me.
Left side, ma'am.
Okay, now Ramya is saying it is left side. So is that correct? Is Kusuma agreeing with that? Kusuma, what do you think?
Yes, ma'am.
So all are agreeing, right?
Yes,
Since
ma'am.
friction is an opposing force, it will be acting opposite direction towards the motion. Therefore, friction will be acting towards the left. So it will be acting in between the wheels and the rod in this direction, towards the left. Okay.
Okay, ma'am.
Now let's see if friction is same for all surfaces. Will it be same?
No.
I got one no.
No, ma'am.
Yeah, someone else is also saying no. Okay, so we will
Depends on the surface, ma'am. Surface and the object.
Depends on the surface and the object. Okay. So we'll do an activity and then we'll find out whether it is same for all surfaces or will it be different. So I'm getting the answer different. So let's check. So we need some wooden board or a cardboard or exam board and some bricks or some books, a torch cell or a cylindrical, anything that is cylindrical, like which doesn't have any sides, so pointed sides or something. Then a cloth, wrinkle-free cloth, and some sand. So now we are going to see an activity. Okay.
Okay, ma'am.
Sure. I have a cardboard here and some bricks. So a torch cell and a cloth and some sand. So now I'm going to stack up the bricks or the books, and then I'll take the cardboard and place it in a slanting way. So I am making an inclined plane. So there is a slanting there. And then I'm going to take the torch cell and drop it here. So it will roll down. So then notice that the distance it covers. Okay. So when I place a cell here, it will roll down and it will move somewhere. So we are going to note down the distance covered. The first case is we will be taking the tabletop as it is. And then the second case, we will spread the cloth here and then again repeat the activity. And in the third case, we will put some sand and then repeat the activity. So in which case do you think the cell will move a minimum distance? Okay, I'll show you how we will do this activity and then I'll ask. Okay.
Okay, ma'am.
Okay, ma'am.
One second. Yeah. Sorry, so I'm placing the cell here and rolling it. So look. So now we will note the position of the cell. So where is it stopping? So I have noted it down. And now I'm going to spread a cloth and then again repeat the activity. Do you think the cell will cover a more distance, or do you think will it cover less distance?
Less distance than first one, ma'am.
Less distance than first one, ma'am.
Yeah, I got Sirishma's and Rajarajesh's answer that it will be lesser. Okay, what do you think, Mokshita? What do you think? Will it cover more distance in this case? Now I have spread a cloth there. Are you agreeing with them? Yeah, Pranati is also saying less distance.
Yes, ma'am.
So you are also agreeing that the cell will cover a very less distance. Okay, let's see that. Yeah, so let's look at the position now. Yes, as your predictions is correct, that cell traveled a lesser distance in that case. In the case where we spread the cloth, than that it covered the distance it covered when there was nothing. Then there was the tabletop. Nothing on the tabletop. Yes. Now we are going to spread sand on the cloth, and then we are going to roll the pencil cell. So now what happens? Will the distance be greater or will it be lesser? What do you think?
Less, ma'am.
Yes, ma'am.
Yeah, I'm getting answers. It will be less. Okay, let's see if these predictions are correct. Yeah, less distance than both. Okay. Yeah, your predictions are again correct. Look, so again, when you look at the distances, this is the case where minimum distance the cell traveled, right? So in the first case, it traveled till the longer distance, and then it traveled when we spread the cloth, then again the distance reduced, and when we placed sand over there, again the distance reduced, right? So now let's look into these questions. In which case the distance covered is the minimum?
Sand.
Sand.
Sand, ma'am.
Yeah, so everyone saw that, right?
Sand, ma'am.
Yeah, when the table was covered with sand, the distance covered was minimum. Okay. Then why is the distance covered by the pencil cell different every time? Why do you think?
Due to the surface.
It is hard, then the friction will be less, ma'am.
Okay, due to the surface, it will be harder when due to friction. Okay, Pranati, can you elaborate that?
If the surface is harder, ma'am, means not smooth, then the friction will be less, ma'am. The object will stop in minimum distance.
Okay, so you are saying that when the surface is harder, friction will be lesser. Is it like that?
Yes.
So you are saying that when the surface is becoming harder or rougher, rough, then the friction will be lesser.
More, ma'am.
Okay, then friction will be greater. Is that your conclusion?
Yes, ma'am.
Okay, so now Pranati is arriving at a conclusion that if the surfaces are rough, then friction will be greater. So let's see if that is correct. Is there anyone having such conclusions now? Something like that? So that is the reason why the distance covered is minimum. That is what Pranati is trying to say. So let's see. Now, does the distance covered depend on the nature of the surface on which the cell moves? We saw that in 3 cases the distances were different. So does that, the reason could be because of the surfaces, because of the nature of the surfaces?
Yes, ma'am.
Yes, ma'am.
Okay, I'm getting so many S's. So let's see that. So this cell stops in each case because Okay, as from what you have seen, from what I have got the answers. Let's look into these cases more elaborately. So here, so every surface will be having some irregularities. So however smooth the surface may be, there could be some irregularities. So here I have a picture of a table and a book. So we have magnified portions of the table top and the book. So you can see the surface of the book. That is the blue portion and the table, surface of the table. So in between you can see so many irregularities, correct? Though it appears to be smooth, you can see so many irregularities here. So they are not as smooth as they seem to be. So there are minute irregularities. Even those surfaces which appear very smooth have a large number of minute irregularities on them. So now as Pranati and Srishma were guessing, friction is the reason why the cell is stopping at every time. Every time it is because of friction. Now friction is caused by the irregularities on the two surfaces in contact. So when the cell was rolling down, the cell had some irregularities and the table had some irregularities. So when friction is so we can say that the irregularities in between these surfaces is making the cell to stop in all the cases. So you have seen that in the first case, the cells traveled a very far distance. Why is that? Now the surface was smoother. So in the third case, when there was a sand, so you can see that irregularities were many. So even with your eyes, you can see that sand is irregular. So the surface became irregular. Surface became rough. So then what happened? So the cell traveled a very short distance. So then that means that in the third case, the irregularities are maximum. So irregularities become maximum means the friction is becoming greater there. So friction is caused by the irregularities on the two surfaces in contact. Okay, are you getting that?
Yes, ma'am.
Okay, now Padma, can you read this statement? So the first one.
Irregularities on that
No,
only,
the
ma'am.
first one. Friction is caused.
Friction is caused by the irregularities on the surface in contact.
Two surfaces in contact. So friction is caused by the irregularities on the two surfaces in contact. Now, can you read the second statement?
Irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to come interlocking.
Yeah, to overcome interlocking. So, yeah. So, since every surface is having some irregularities, so when something is moving or something is kept on a table. So here, let's take a box is kept on a table. So in between there is some irregularities. So then what happens? These irregularities get locked up. They get interlocked. So they become so strong there. So the irregularities get fixed there. They are becoming interlocked. So then to move that, we need force. We need to apply more force to overcome this interlocking. Okay, then, so what happens? On rougher surface, there will be more irregularities, as I have been saying. So on rougher surface, there will be more number of irregularities. Since friction is caused by the irregularities on the two surfaces, what will happen? Friction will be greater or lesser? What do you think?
Greater.
Yeah, friction will be greater. So the friction is greater if a rough surface is involved. So can you note this point? Force of friction will be greater if a rough surface is involved. Yeah. Rajarajeshwari, can you read the last statement? The one in blue color?
So the force of friction is greater if a rough surface is involved.
Yeah, the force of friction is greater if a rough surface is involved. Okay, then what do you think if you have a smooth surface and you are
will be less.
okay, Pranati? I didn't hear. Can you repeat?
The friction will be less, ma'am, in smooth surfaces.
So Pranati is saying the friction will be low when the surface is smooth. So what do you think? What others think? Let me ask. Yeah. Mokshida, can you try? Will the friction
Ma'am?
be lesser? Yeah.
Ma'am, but sometimes it depends on the both of the objects, no ma'am.
Yeah. So yeah, if you have a ball and suppose you are having a ball, so ball is rolling in on a marble floor. Okay, take that case one. Okay, now ball is rolling on a rod. So in which case friction will be greater? Tell me in which case friction will be greater?
In the second case, ma'am.
In the second case. So in the second case, the rod, the ball is rolling on the rod, and then the surface is having more irregularities, right? So the friction depends on this irregularities on both the surfaces.
Yes,
If
ma'am.
both the surfaces are also irregular, then the friction will be maximum. Okay.
Okay, ma'am.
Is that clear, Sirishma? Clear? Is that clear?
Yes, ma'am. Clear, ma'am.
Okay. And now, what happens when the surfaces in contact are pressed harder? So will friction increase or decrease?
Heat will generate, ma'am.
It will generate heat.
Heat, ma'am.
Okay, so let me take, okay then, I'm keeping a box on the tabletop as we have seen in the example. Now I don't feel any heat there. So I'm pressing down the box. Suppose I'm pressing down the box. Okay, then do you feel any heat there?
No, ma'am.
No, ma'am.
So
If we scrap the box on the table, then we will feel heat, ma'am.
if we
Scrap.
Yeah, if we scrap, then definitely you will feel the heat. So similarly, if you rub your hands, you will feel the heat. Some cases heat will be produced. Okay, we'll come to that in the next classes. Okay, now, so what happens when the surfaces in contact are pressed hard? So here, let's see this through an activity. So here I have a robot, like this is a robot, and he is going to push the box. So here you can see the speed of the moving box, and you can see the forces here. So let me show it to you now. So now you can see he is applying a force in this direction. So towards right he is applying, and frictional force between the box and the rod, the rail, it's towards this direction, in the opposite direction. Now he is applying 50 Newton force here. Now the box is not moving. So let's increase the force. So now it started moving. You can see the speed here. So it is moving. Now let's check what happens. So at 150 Newton, the box is moving. Now I'm going to place a man on top of the box. So now the box is pressed down towards the rod. You can see that, right? So now, okay. So now the man will be pushing the box again, and let's see what happens. You can see that frictional force is greater. So look at the speed. What is happening? So speed
Decreasing, ma'am.
Yeah, speed is decreasing. Okay. What about the frictional force? So now the box is
minimum.
frictional force is minimum. Is that
More, ma'am.
okay? Frictional force is becoming more. You can see this by the size of the arrow also. Frictional force is more when the surfaces are pressed harder. Correct? So let me put another thing over Kim. So now I'll increase the force also so that it starts moving. So I am applying force. Frictional force is in the in the opposite direction. It is also increasing. So the applied force is increasing. Now I'm increasing it again. Okay, it started moving. So when I applied maximum force, it is moving. So when I have, so what does this mean? When I have the box pressed harder and harder, it needs more energy, more force to move the box, right? Move the whole thing. So frictional force is greater when two surfaces are pressed harder. So can we say that frictional force is greater when the surfaces are pressed harder? So when the surfaces are pressed harder, frictional force will increase. So now we have seen two factors which are affecting friction. Can you state that? So what are the two factors which are affecting friction? So in the first, yeah.
If the pressure is more on the object, then the friction will be, means if weight is more on the object, object will move easily.
Okay, weight is more than the object will move easily.
Won't move easily, ma'am.
Okay, won't move easily. So one of the factor is how harder you are pressing the surfaces, right?
Yes, ma'am.
Okay, and then let's look at the first one. So in the first activity we changed the surfaces, right? So friction will depend on the surfaces also.
Yes, ma'am.
So the two factors are, one is the nature of the surface and second one is how hard the surfaces in contact are pressed together. So when the surface is rougher, frictional force will be greater.
More.
Yeah, more. So when the surface is smooth, frictional force will be
Less.
Yeah, less. So now, can you answer? Why do we fall down when we step on a banana peel?
Because the friction
is less on.
Yeah, because friction is less. Let's look at it. What is happening there? So here, so I have magnified this portion where he was standing. So this is his shoes. This is his the floor. So these are the irregularities. And in between there is this banana peel. So the fleshy part of the banana peel, it is interlocked with the floor and then the surface is becoming smoother. So that's why it's becoming slippery and that's why we fall down when we step on a banana peel. So the frictions becomes very low when the surface becomes smooth. Okay?
Okay, ma'am.
Yeah, now tell me, why is it difficult to walk on a wet bathroom floor?
Because the friction
is less on the floor, ma'am.
Yeah, because friction is less. So similarly, we can say that, so this is the floor, so this is the water, and this is our legs, the shoes. So instead of banana peel, consider this is the water. So then what happens? The irregularities are becoming
less.
Filled with water. Yeah, irregularities are becoming less because the water is filling that irregularities and making the surface smooth. So the friction will be lesser in that surfaces. So then what happens? We will slip. It is very difficult. So we need to be careful when we are walking on a wet floor. Now, so today we have seen what is friction. So friction is a contact force and we have seen that it opposes the relative motion between two surfaces that are in contact. Okay, then we have seen two factors that are affecting friction. So can you try that? One factor? Yeah. Okay, who will answer that? Kusuma, can you try? Can you give me one factor which is affecting friction? So friction depends on.
Kusuma, can you try? Can you give
Kusuma?
friction is less? Let's look at what is happening there. So here, so I have magnified this.
Okay, then Sirishma. Yeah. I'm getting answer. Yeah.
Yes, ma'am.
Distance. Okay. Okay, Ramya. Okay, whoever wants to answer now answer. So I have given two arrows, so two factors are there. So friction depends on two things. So give me one.
Surfaces.
Okay, surfaces. Yeah, I didn't see you. Sorry. I'm getting answers through the chat box also. Yeah, surfaces. So nature of the surface. When the surface is smooth, friction will be less. When the surface is rough, friction will be greater.
More.
Yeah, more. Okay. Now the second thing is how hard the surfaces are pressed together. So then the interlocking will be maximum and the frictional force will also be maximum, right?
Yes, ma'am.
Yes, ma'am.
Okay. Now let's quickly do a check. Yeah. Now you have to answer through the chat box. This is simply true or false, okay? Answer through the chat box. I would like to get all the answers. So the first question, state true or false. Friction is a non-contact force. Is it true or false? Yeah, I'm getting answers. So I got 5 or 6 answers now. Yeah, I'll give you 10 more seconds. All have to answer now. Phanindra, Phani Kumar, what is your answer? I'm not getting your answer now. So friction is a non-contact force. Is that true or false? Yeah, so I'm getting all the answers false. Let's see. Yeah, it is false. So friction is a contact force. Now let's look at the next question. So the second question, friction opposes the relative motion between two surfaces in contact. State true or false. Yeah. Quickly give answers. So I got 4 or 5 answers now. Yeah. Yes. So all the answers are true. So let's see whether it is true. So it was correct. So friction opposes the relative motion between two surfaces in contact. Now let's see the next question. This will be a little tricky. So let's see. State true or false. Writing on a paper is possible because of frictional force. What do you think? Is that a true statement or a false statement? I got 2, 3 answers. Yeah, writing on a paper is possible because of frictional force. So what others think? Only 5 have answered now. Yeah, Pranati, then Sirishma, Mokshita. Mokshita, what is your answer? No. Is it true or false? I didn't see your answer. Yeah, true. Yeah, okay. Then what do others think? Writing on a paper is possible because of frictional force. Yeah, Ramya has also said true. Okay, then let's check. It is a true statement. Now, Pranati, can you explain how is that how do you say it is a true statement? So writing on a paper is possible because of frictional force. Can you explain that?
Yes, ma'am. If the frictional force is more, it would be difficult to write, ma'am. We cannot move the pen easily.
Okay, so the question is writing on a paper is possible because of frictional force. So if you are saying that if frictional force is more, then it is difficult for you to write. Okay, is that your reason? Now, you are writing on a book or a paper. So let's suppose that you are taking a pencil. So you are writing on a paper. So the irregularities on the paper is filled with the lead of the pencil. That's how you are able to write. And you won't be able to hold a pen if there is no friction. Okay, that's the reason for this statement. So writing on a paper is possible because friction is there. So if there is no friction, you won't be able to mark a point or draw something or write something. Okay? So that's the reason. So we will see all this in the next class also. Okay? Now let's look into the next question. So, yeah, Ramya, can you read this question?
Yes, ma'am. You spill a bucket of soapy water on a marble floor. Accidentally, would it make it easier or more difficult for you to walk on the floor? Why?
Yeah, so give your answer like, will it be easy or will it be difficult? Yeah, difficult. I got Krishna Kumar's answer. Are you saying something, Ramya? Yeah, difficult. Difficult. Yeah, I'm getting answers here. Okay, so all are agreeing that it is difficult. Now, why is it difficult?
The soap